Good afternoon again. So we are now going to introduce the use of the software, creating new project or using existing project and prepare the simulation. In this part, we will have two parts, essentially. One which is in relation to the drawing editor. That means where you are creating a new project, adding layers, entering the height of the building, selecting multiple building at once, or delete building, or adding new layers, moving, and then selecting a version for simulation, then looking at the simulation setup before running the simulation. The next part, which is the next part 2 is result visualization, and this one will be presented in a next, and then there will be again a next session with some typical example of processes that we can do with this software. So first is the installation of the software is quite straightforward nowadays. It is, and that's intentionally that we made it as simple as possible. So when you install the software, you first have to install OpenFOAM package, which is a version 1.026 that we have provided, which corresponds to a recent version of OpenFOAM for Windows. And then after that, you have to run this as a system administrator, and the two installation, it's better to run them as a system administrator. Then once you have installed the OpenFOAM engine, then you install the interface software Vayu Pravah 1.027. And then remember one thing, all the files should be saved under the C drive in the system, not on another drive. And if you had any previous version, you should delete it before reinstalling. And it has been installed successfully on Windows 10 PC, but we have also checked that it can run on Windows 7 or Windows 8 machine. So this is for the introduction and how to install it. We can discuss question later. Now, the main window of when you start up Vayu Pravah, you get actually three main tabs, which are drawing editor, simulation setup, and results visualization. And on the left, you can either create a new project or open existing project. When you launch it, you get also a small window below Vayu Pravah where you see the kind of project which are already there and that you can then open. So now if we look at getting started with a new or existing project. So the main structure, just as a reminder, you have a drawing editor, then you have the simulation setup, and then you have the result visualization, which are three components of the software. So loading an existing project, you can choose open, browse to look for a project existing which does not appear here, or setting up a new project. And then you can select one of the old, or as you want. Then if you want to work on an existing project or a new project, you will have to add layers. That means any block or any building that you are getting from a DXF file has no height. It is a 2D file to start with. That means it is a two-dimensional file. But once you import files, then you will have to give them a height and then put them on a given layer. You can have different layers. We'll show that later. And then again, to remember, you will have project which can contain different cases. One cases can have different configuration of buildings once you have modified them, and you can have different cases there. And then after, you can work on variation. That means you will see how you can modify some base project that you have defined. And so then just to remember and show you on the left of the, when you are in the drawing editor, you have choose and create new cases, or choose and develop new version. I will show you more in detail what it means. So first, when you import a DXF file, you can, when you import the file, you can select the building you want. The one which are in blue in this case, by default, you are getting all the building shapes which are imported. And if you want to change them or select only few of them, you have to click on them. I will show you after what it means. And then you have to install it on the first layer to start with. And then you have to select the height of the layer in case it's not yet the first layer, but the second layer, but that will come later. I think about the DX file, what is important is that the DX file must be all coplanar. That means they must be all in one horizontal plan. And then the polylines that you use to define a different composition of, typically, for instance, an open facade. You can see here an open facade with elements which are defined. Each component that you draw should be a polyline which is closed. So whether it is a big block or smaller component, they must be closed. That is very important. Otherwise, sometimes you may have trouble in importing the files. So once you have imported the DXF, then you can select the building you don't want or you want. So that means out of the blue, the green, the gray one are not selected. You have just to click on them during this phase of the project. And then after, so we just show here how, just to see on the interface in a dynamic case, you can create a case, you can give a name, and if you want to save the name, then you create a new case, and then you go and import a DXF environment. Then you can decide if you want to remove some of the elements. Then it starts from the ground, and then after in the drawing editor, once you have loaded the thing in the editor, you will see that the building of each of them has a number, and they are on the first layer, and then you have to give them the height which each of them has, or all together. So you have once you have entered the building, the first one, number one, is normally selected by default, but you can change the selection of the number of the building you want, and you have to set up the height of the building, which means the first height you have to set up is the height of the bottom of the buildings in this layer, and then you have to give them a height, and the height can be different. And here you can also move the building. Once you have created a variation, you can move the building at different place. You can see here that the 6 and 7 have been moved and that the 9 has been rotated. So now if you see in here, you give the height of the building, which is the difference of height between the bottom and the top of this building. And then after that, you can also move the building. You can see that you can either translate a building. When it's brown, that means you have clicked on it and selected. You can also rotate the buildings separately or in group, depending on what you want to do. And then you can also select multiple buildings at once. That means by using this this icon, you can select by group, when you have this blue, then you see all these brown buildings, they have been selected, so you can set up their height differently from the other one. Then after you have set up the first layer of buildings, either you are going to work on blocks only, so you are not going to add a second layer, but you can also add layers which can be either of different shapes or we could be also internal flows that we will see a little bit later. And so you have to, when you add the second layer, you have to add it on top of the first level of the layer. And then here, the concept of the layer in the building, let us explain a little bit. You can define buildings which have, let's say, a kind of block layout for the bottom of the building. Then you can reach a floor that you want to have open, for instance. So you start by having, let's say, the sill level, where you have a facade profile, but not yet open. This is the B layer, if you want. And then after that, the C profile is an opened part, so you can add it on top. And then after you add again, for instance, the closed facade with the design for some height on top, and then you add again the component A, which is the block on top of it. So like this, you have, this is one example for a long building, let's say. We can also show it for a building which is more like an internal courtyard shaped building. So you have the bottom of the building here, which the layer is at 0 meter, and it goes up to 15 meter, right? So this goes from 0 to 15 meter. Then at 15 meter, you add, here we have considered that we have 3 meter of height with openings without a sill. We did this for simplicity. So here you can see that here you have the building, you can see the openings here, and then you can see it in a clipped plane, so that we have made a cross section here of the building. So you can see that this specific floor is having openings so that the air could come from the shaft or be driven from outside into the shaft to go outside, to go on top of the building. Then we have the higher portion of the building, which is again in a block form, but which has still the courtyard open like the bottom. And then on top of it, we add at the height of 28 meter, which is here, we had a kind of chimney above the building, which helps in creating a negative pressure in the courtyard with the wind passing above the building. So you can see that this is one way of adding layers and using layers to make building which have a part which is block. It means it's the calculation is very fast, because then the mesh is less refined, and then you have the part where the mesh will be more in detail. Then after, once you have created one case and you have one first version, if you want to change the version, you just duplicate the version 1 by this button, and then after you can modify the case, this case with a new version, and you can run it again after. So we can see here when you add a layer. So this is an absurd example, but it's just to demonstrate the things that if you add this shape of building on top of the other one, which doesn't make sense, but it's just to show you the possibility of the software. So you see we have this block that can go above the other one, and we can then show how the different layers are considered. So this is just to show the capability of the software, not to show a real case in this case. So now that we have gone through, let's say, the basic understanding of the interface to import and create cases and then their variation, then we have to go to the simulation setup. The simulation setup is this, with this tab, then you are getting different information there. Once is you can define the height. You can change the height of buildings with their number by selecting each of them in this table if you want. Then you can also have a clipping plane, which allows you to visualize if you have created already many layers to see how if it's correct in 3D. Then after, you have to define the simulation environment, which means that I mentioned the height and the clipping plane where you can visualize cross-section. But then after, you have to choose the environment, choosing the kind of wind profile, whether it is city, suburb, village, forest, etc. I think we are thinking of adding a user introduction of this specific profile. Some people have done some specific local measurement. Then after, you can enter the wind direction, which is specifically sort as the wind you would want to have at night during the hot season between 10 p.m. and 6 a.m., which is the typical direction. Like, for instance, if you are near the seashore on the west, you would have southwest wind normally quite often, but this depends, of course, of the area. And then you have the reference height. If you have data from weather station, normally you have the height of the mast, which is taken at 10-meter high normally. And then after, you can choose also the number of CPU you want to allocate. Suppose you want to work with your machine and you have 4 CPU. If you select the 4 CPU, then your machine will run almost 100% on the with all the processor, and it will be more difficult to use it maybe at the same time. It may make it so slow to react. So if you want to keep some margin to work, you can reduce from 4 to 3, and then it will use only 3, approximately 70–75% of the total power of the machine, so that you still can use it for other office kind of or Excel or different application. Then here we have 2 different ways of doing the simulation. The approximate is intentionally the one which will be certainly used most, is the one where you can quickly get answers. Like, for instance, you have one configuration of a project, you run it, then you modify. A few minutes later, you modify again, and you get runs, and you get the results within few minutes, normally something like 3 to 5, 6 minutes. When you are working with blocks, you can directly see the impact of the variation you are doing, and see how the wind is flowing between the software. So then you can clip also. That means you can choose to make a clip which is horizontal or vertical in both directions. And after that, you can, before running, it will ask you to save the project. If you didn't do it before, it will ask you to save your project and save at a location. So we recommend that we make a special location on your C drive, so you have all the files at the same place, but you are free to do as you want. Then after, once you have run, as I told you, you will certainly start by using maybe full CPUs and then approximate solution. And depending on the situation, as I mentioned, if you are on detailed, if you are working on blocks, normally, if you have only blocks, it goes in a few minutes normally. If you are going with an internal flow, it may take a little bit more, like 20 minutes maybe, but then you get this information, all the airflow can flow into the building. And then, which means you can take care of different kinds of geometry of the facade. And then if you are going to the detailed mode, then as the meshing is much finer, then you are likely to end up in a couple of hours of simulation. That can really happen. Then during the simulation, you see this meshing bar, which is blue, which when it's blue and this small green arrow, it tells you the meshing is over, and then it shows you during the simulation an estimated remaining duration, which is normally quite good in terms of accuracy. We have checked it on many cases. So, which is that now, if you look at a kind of summary, so you can change the height of the buildings also in the simulation setup mode. So you can see, you can visualize the height of your buildings. You can clip the plane if you want to cut. Suppose you have internal zone that you have defined, you can also check. This is not shown here, but that's what could be done. Then you can also even look from below or top, depending on the clipping plane on which side you are doing. Then you can launch the simulation, saving, and then you get the meshing, and then you can enter into the simulation. So thank you for your attention, and the next part will be the part 2, where we are presenting the visualization of results and how to analyze them. And then after, we have a part 3 where we will show some example of actual process, or some example of possible process for the design. So thank you for your attention.